Hi everybody. This is a tutorial video. It's a long form tutorial video for showing process for building onto a uh, processing P5.js project. So for those of you who don't know, P5.js is an animation and simulation drawing and animation library, so you can create games, interactive art, simulations, animations, or just images. And this works with the canvas element um, on a web page. So the canvas element is a cool display web page element, and P5.js is built to be very easy to use, very user friendly, um, to interact with the canvas elements so that you can create compelling drawings, animations, simulations, whatever you'd like. If you're interested in seeing some example projects and how people build things, you can go to the showcase.p5js.org for whatever year you would like. There's multiple years of the showcase, the community showcase, and you can look at different levels of projects. Some of these probably uh, took hundreds of hours to create, as well as some of these projects require understanding of more complex mathematics or things like matrix mathematics, linear algebra. Um, so, obviously, some of these folks are math majors or computer scientists or did some of these projects for university, and some of them just did it for fun. So, obviously, as your technical level and technical ability improves, it will increase um, the level of complexity of projects that you are able to create. So, we're actually going to start with a simple project. And this project is based on the Space Invaders game. Space Invaders, for those of you who don't know, it's a I'm not sure what arcade game or system it was originally made for, maybe the Atari or something. But the basic functionality is you have a little cannon and some bunkers protecting you. It only lets you fire one bullet at a time, so you have to hit something before you can fire your next bullet. And you have these alien spacecraft or alien individuals who are moving side to side and shooting at you. Um, Sorry about that. I had to cough. So you have alien individuals shooting at you, and they're moving a few times per second in a direction, then they hit the side. Then, after they hit the side, they move down. They also speed up. Occasionally, you have a red UFO moving across the top. You can see as there are fewer and fewer space ships or aliens, they are moving, the rows and columns are moving faster and faster per second. It is slowly increasing in speed. I think originally this functionality was unintentional because it was based on the processing speed and rendering of all of the visual elements on the display. So as there was less work that needed to be done, it ended up uh, running faster. But in later versions of the game, they just built this in as a feature. So if there's fewer enemies on the screen, they're moving faster, so they're harder to hit. You can see we have lives, so if we get hit by any of these bullets from the aliens, we will lose a life. And if the aliens get too low, they will hit us, and actually we will lose the game, I believe. The game will be over. Or if you get hit 3 times by the Space Invaders shooting at you, you will also lose the game if you only have 3 lives. Every time you complete a level, I believe you get another life. Yeah. So you see, we got another life, and you can have up to, I don't know, 6 to 8 lives. I can't really remember. You can decide for yourself how many lives you want to give the player. So you can see this game is actually pretty simple. Like, um, if you just have a basic strategy for dealing with these Space Invaders, it's pretty easy. It's not that hard to um, shoot them all. So actually, if you time it, uh, and move left or right a little bit as you're shooting, you can just clear a whole column of these at a time, and then they're still just moving. And you see when they hit the side, they shift down and they move a little bit faster. But so we will lose if this set of aliens, if this square of aliens ever gets to our row where the player is on. We will lose the game, but you can see it's pretty easy to just shoot them all and prevent them from getting to us. So we can destroy this bunker and just shoot at the aliens. So this game is not very hard. Obviously, from the base game, you could... Oh, I just got hit because I wasn't paying attention. Yeah, so this game isn't very hard. You get a new life every level that you clear. So if you're clearing levels pretty easily, then you could be playing this game for a very long time. As you play harder and harder levels, basically the aliens will get lower and lower in the starting position and faster and faster. So your strategy might have to change. You might have to first clear the first row of aliens instead of doing a column strategy so that you don't immediately lose on the first or second shift down. I don't really know if there's an end to this game or what the end is. I haven't played Space Invaders that much because I usually lose interest after playing for a few levels. Obviously, this game is very old, and it was built on very early recreational computer systems with pretty slow chips compared to what we have now, right? But its simplicity makes it a good programming project to start with because with high-level programming languages like JavaScript or Python and libraries like P5.js or other libraries for making games and animations, it's pretty easy to get started building these games and adding on to them. Pretty conceptually easy. You don't have to really uh, be any kind of computer genius, and then the memory management and resource management for like RAM and processor, um, you know, prioritization, things like that. It's all done for you by the language. So you just have to work with data and then the logic for handling this data, right? So some things to keep in mind when we're making games. Uh, we are running a function which is updating the game state So it's going to be updating all of the elements that we see, and then it's also going to be drawing them or rendering them to whatever display we have set up, right? So we have to think about how are we interacting with this as a user and changing it, right? How do our key inputs matter? So like the arrow key inputs and the space bar to fire bullets, right? And then anything that's moving has to be tracked and properly updated. So you can see the aliens are all moving, the bullets are moving, the player cannon is able to move, the bullets from the aliens and the score display are all moving, changing, updating dynamically based on the interactions in the game. So let's go ahead and just exit out of this, and we're going to take a look at our starting code. So you can also refer to the notes for this. So you can see that I've actually created some part 2 files. So I'm going to split this on 2 sides so we can see both the HTML and the JavaScript. So the cool thing about this project is that since it is a processing project, by using a CDN link, a content delivery network link, we can download the library into our HTML page just by having this link here. So we have our HTML right here. It's very simple. You can just copy this and paste it in to your file. You can see our second JavaScript link needs to be to the file that we're going to be working with for the drawing and all the other data that we have in here. So we can see that the name of my file is part 2, so I need to change this to be part2.js. We can see that VS Code has autocomplete because it recognizes the file name in this project directory. So the starting template, which I am providing, you can just copy the code into your JavaScript. You need to make sure whatever you call this JavaScript file that you have the same name in your import link, okay? Just be aware of that. And this should be in a folder. I have called this folder Space Invaders P5 because we are making Space Invaders clone with the P5.js library. So very simple, you don't really need to download anything. You just need to copy these files and get started. So actually, if you guys want to take a look at what this looks like, I will show you what the project looks like so far. Okay, so this is interesting. For some reason, this is not moving. So I'm not sure why that is. Give me a second to figure out why this isn't working. Okay, that took me a little bit to figure out, but basically I found out that we were missing the move call on the aliens down in the draw function. So I'll show you. You can see all my console logs I have in here. The numbers are the frame count, so that's how many frames have been drawn. You can see that we have some console logs for the true false value of the move aliens Boolean value. You can see most of the time it's false, so because we don't want to move the aliens every single frame, we're moving them only a few times per second, right, based on some kind of number. When moving the aliens hits, then you'll see that all the circles update their position. They're moving in a certain direction. So you can see from all these console logs that this simulation is updating 24 times per second. So it's hard to see exactly how many times per second it's updating, but we can look in our code, and by default we know that the frame rate of the P5.js drawings, animations or simulations is going to be 30 frames per second, but in our setup function we have changed it to 24 frames per second. Okay, so the first thing that we're going to do is we're going to just do a basic read through of this code, and we're going to explain all the different sections of the code and what they do, and then we are going to talk about writing some notes for outlining additional functionality, and then we are going to build onto this project. Okay, so first things first, this project is assuming that you understand the basics of ES6 class syntax. I don't know how many features I'm going to add into this. I might just keep it basic. I might add in a bunch of syntax examples over time. I don't know, it just depends on what I feel like. But for now, we're just going to start with the basics. So we have some classes. So I'm assuming you know what classes are. I'm not going to explain that. If you don't know what that is, go learn about ES6 classes and object-oriented programming, and then you can come back to this video. But we have some classes. We have a pretty much empty game class, a pretty much empty level class, which would set some properties like the level, the alien move frequency, which, as a starting value, as the levels progress, you probably want this to be faster and faster, and you probably want this to be like based off of the level number in some way, right? Because as the levels progress, you want to change the speed and the starting position of the aliens. We have some global variables that we're declaring. So this code base is not a pure object-oriented code base yet. It's some procedural code. We can maybe refactor this later to all just be in some kind of global object, like for like options data or something like that. So we're creating just an empty variable, declaring the variable ship, an empty array for our aliens, an empty array for our bullets, setting our frame count to 0, and setting the alien move frequency. Then we have our first class here, the ship class. So this is the player. So actually we could change this to be player, but ship is a good name for this. If we ever end up wanting to expand the functionality of player movement to be in two axes, instead of just the x-axis, if we want to allow the player to fly around on the screen, then it makes sense to just call that a ship, right? You can call this player, you can call this ship, you can call this cannon, whatever you want, whatever makes sense to you in your game. We have our constructor. We're setting the X position to be the middle of the screen. Then we're setting the direction of the ship to be 0. Then the show method. We're going to have a show method in all of our classes to paint the representation of this object on the canvas. So this is just a rectangle right now. It's very simple. So it's putting the rectangle at the bottom of the screen. Set direction. This will change the direction variable, the direction property of your player ship. This is for to be able to have player movement. So when you press a key, so actually that's at the bottom of the screen. So if you have, this is the player control section down here. So if you press keys, it will change the direction of the player ship, and then that will cause the player to move position. All right, so then we have the move method. So this is important, right? Because this is what runs when we want to move. And this is actually going to move us 5 pixels in a negative or positive direction, right? So remember in P5.js, 0, 0 is the top left corner. So positive direction would be to the right, negative direction would be to the left. For the y-axis, that's vertical. So 0, 0 is top left. So adding more to the y direction means we're going down, and subtracting means we're going up. Okay. So that's pretty simple. We could definitely add on to this. We have the alien class. This is for creating an individual alien. Right now, this is just a pink circle. That's what this show function is doing, is drawing a pink circle at the location. The constructor takes 2 arguments, an x and a y value, and we also have just a default direction, which we're setting to 1. If it's positive, it's going to be moving to the right. If it's negative, it's going to be moving to the left. Then we have a property for checking if we need to delete it, which is initially set to false. And you can see here we have a show destroy, which updates this to true, the to delete to true. We have a move function. This moves it in a direction. See, it's moving 10 pixels in a direction. And then we have shift down. Shift down is the functionality that we have when the aliens hit the side. So right now you can see that the circles, the edge detection of the circles, because they're based on the center point of the circle, we see that it's not registering as an edge hit until the X either hits or overlaps the boundary of the canvas. We could potentially change that if we don't like that. So all right, so that's the alien class. Then we have the bullet class. Again, a constructor, X and Y position. To delete true or false, we initialize it to false, right? So this bullet is going to be shooting up. The show function, which will paint the little circle, which is the bullet. If you don't like circles, you can use like a rectangle or a square or any kind of shape you want for the bullet. The evaporate function is setting the to delete property to true if it runs. Then we have a hit detection method. This will check if the bullet has hit an alien. So we have like d equals distance, this dot x, this dot y, alien.x, alien.y. So this is checking the distance between the two coordinate positions. It's just running a calculation of the length between the 2 points. And so if that length is less than 30, then we will register as a hit. And that is because the aliens are 60 pixels wide and 60 pixels tall, which means that the radius is going to be 30 pixels, right? Because the diameter is 60, so the radius is 30. So if you are within 30 pixels of the center point, which is the X and Y, which is going to be the center point of the circle, then you are hitting the circle, right? So then that hit detection will return to true. Okay, so we can see, hit detection is something that's very expensive when it comes to our processor, because you have to run a calculation, and there's also an if statement here, which is not great. Because we know if statements are slow, right? Then we have, and keep in mind, if you're running hit detection, you usually have to check on a lot of different things, and there's definitely ways to optimize how many times we have to do hit detection. There's ways of avoiding doing a whole bunch of unnecessary processing power, processing work. So, but that's later on down the line. We'll talk about that in later videos, right? Right now, we just want to add some more features to this game. Then we also have the move method. The move method is always just going to be subtraction in a y direction because the bullet's not going to move in the x direction. It's just going to be fired from a certain position. And it's just moving up, right? Okay, so those are our starting classes. Now, in processing, we have a setup function and a draw function. Our draw function's pretty important. Setup is for setting up the canvas size, which right now is 1,000 pixels wide and 500 pixels tall, and then setting our frame rate. And then here we are creating an instance of a new ship. This is a player ship. And then here is the array. This is the array, which is, this is the loop, which is creating 12 aliens. So we are pushing we are creating an index and pushing a new alien into it. Actually, what we could do, we could restructure this code. We could just say aliens dot push. I believe this will work. Yeah. So it does the same thing. This is just a slight change in the syntax. So aliens.push. So we're looping through here and for 12 times. And we're pushing a new alien in. So alien takes an x and y argument, right? So x is going to be I times 60 plus 60. And then the y position is going to be always 60. So this is kind of hard coding it, right? Immediately we want to think about maybe we need to create some new variables, like alien y start and alien x start, right? And then inside here, we're going to initialize this to 60. Actually, we don't even need an alien x start because we probably want Well, actually, no. Maybe we do want that. So let's also set that to 60. So by creating these variables, instead of hard coding the starting values, what we can do now is we can programmatically set this. So we're going to keep 60 right here, I times 60 plus 60. So order of operations, we know that. And if we want to make this even clearer, we can put this in parentheses, just so it's very clear that this expression is being calculated first. So I times 60 and then plus 60. Plus 60 is basically moving us from 0 on the x over 60, right? So the first alien, it's going to be 60 pixels. The center point is going to be 60 pixels away from the left side of the screen. And we can see that here. So that means that the actual space in between the edge of the circle and the edge of the screen is actually going to be 30 pixels because we are starting this calculation from the center point. We know that this circle has a radius of 30 and a diameter of 60. So then that means the black space is going to be 30 pixels, right? So all we're going to do here is I'm going to say alien x start, which we've set in our setup to be 60. And then this y value, this y start value, we're going to change it to this variable, to alien y start. Okay. And actually what we could do is we could even create a function that's going to just run and create aliens. But for now, this is just a for loop. That's fine. If we wanted to create multiple rows of aliens, because this one loop is only creating all the aliens are at the same y position, and it's just doing this 12 times, so it's just creating a single row of aliens. Excuse me. Then if we want to create additional rows of aliens, think to yourself, this is a little mini challenge. It's pretty easy if you know how to do this. So think to yourself, okay, we have a row of aliens. How do we create multiple rows of aliens? Right? How do we create multiple rows of aliens? So go ahead and you can pause this video if you want. I'll give you some time to think about it. Take a few minutes to think about it. See if you can come up with a solution. All right. So if you've unpaused the video, so we used a for loop, and loops are great for repeating something that you need to do. So in this case, we're creating an alien and we want to do it 12 times. So we used a for loop, so we're repeatedly creating an alien 12 times. So if we want to create multiple rows, we can just have another for loop. So I'm going to call this rows index instead of I. I'm going to start it at 0. So I'm going to create another variable here. I'm going to call this number of alien rows. In the setup function, I'm going to define this to be 4 at startup. So I'm setting up a programmatic for loop. And actually, let's go ahead and do this for the columns too. And I like to put my things in X then Y, X then Y. So row then column, row then column. So we'll change this. And you might say, oh, that's a very long variable name, but I like descriptive variable names. And if we have long descriptive variable names, we won't accidentally run into calling the variable the same thing as easily. Right? We want our code to be readable. So remember, it doesn't really take that much longer to read like a few words in our variable, and it's descriptive so that we don't have to have a comment, right, on what this variable is. It's the number of alien rows. So it makes our for loops not just hard-coded as well, it makes it programmatic. So if we ever need to change this somehow, so then we say number of alien columns. So we want this row for loop that's creating the row of aliens to be inside, right? This other for loop we just created. And then we want the Y position so we're doing math here. The row X starts at 0. The row index starts at 0, right? So alien Y start times row index when it starts at 0, so 0 times 60, that's 0 plus alien Y start, which is 60. So the first row is going to be, the first Y position of the first row is going to be 60. Then for the second row, when row index now equals 1, it's going to be 120 and then 180 because it's going up by 60 each time. Okay. So now when we start this, we actually see we have 4. Okay, so I hope this makes sense. This is a nested for loop, so 2 for loops, and the inner for loop is creating a row of aliens. And based on the number of aliens in the row is going to be based on how many columns of aliens we want, right? And then this for loop, the outer for loop, will determine how many rows that we have. Okay, so we've created basically our logic for being able to programmatically determine like how many aliens we want to create and where the aliens are. So this function, this draw function, is pretty big. So I'll actually even split this, so we might want to look at this in multiple places. Okay, so we are drawing a black background, and this is what creates the animation effect. If we don't do this, then the effect is going to be different on the animation, right? It's just going to be overlapping instead of being just like an animation. It's all just painting over itself. So you get to see the after image of everything that was ever drawn on the screen, which looks cool. Obviously, it's a little bit disorienting because it doesn't like when we hit the aliens and they get deleted, which we can kind of see, but then it gets overdrawn. So yeah, this is like a cool effect, but obviously for the game we don't want this to be the norm, right? This is a fun way to break the game. So we're just going to comment this back in. So we're increasing the frame count. This is just so that we can see how many frames have gone by. This is basically allowing us to keep track of time. We're console logging it so that we can see in the console. We're running the ship.show and .move methods in case we are wanting our ship to move. So this for loop is moves the bullets. And checks if the bullets have hit any aliens. So if we hit the aliens, we obviously want to mark them to be deleted, right? So we run the destroy and the evaporate function on the bullet and alien. And this will set their property of to delete to true, right? And then when we do garbage collection to see like what stuff do we need to delete, that will be true, and those items will be deleted. So this is a big for loop with an if statement with some function calls, some method calls in here, an if statement, and then another loop, and then another if statement, and then some more method calls. So this is some nice little logic here. Obviously, this is going to be very time intensive. This is not like because we're checking it for every single thing. So, we have nested for loops that tends to be processor or it tends to be time intensive, right? If we keep nesting more and more for loops, it's going to be like exponentially increasing the number of processes, expressions that we have to evaluate, right? The amount of math that we have to do. And anytime you do any kind of math or any kind of work, like calling a function or evaluating an expression, that has to use the processor, right? Because you're using the processor to do work for you. All right, so we're still in the draw function. We have this hit edge variable locally defined inside draw. We started out as being false. We also have the move aliens to false. This is checking to see if we want to move the aliens. So we don't want to move the aliens every single frame. We want to move the aliens a certain amount each second. So this is based on the alien move frequency variable, which, okay, I'll keep this still. Sorry, I'll keep this still and I'll move this right side. So the alien move frequency, right, if you remember, we're starting out that it's 12. And actually, I think technically we should refactor this so that the alien move frequency is defined in setup and not up here. Okay, so we got that working. So this little if block, that's basically just determining whether we want to move the aliens or not. If this is true, then move aliens is true. Then we have an if statement here where if move aliens is true, it's going to move the aliens. And then it's going to check to see if we've hit the edge. And if we have, if any of these aliens have hit the edge, then hit edge equals true. And then this else statement here is in case move aliens is false, then all it's going to do is show the aliens. And since they haven't moved, we know that we don't need to run any edge detection on them, because we moved them and then we're showing and then we're checking for hit detection. So the X positions have been updated. All right, so if hit edge has been set to true, then we're going to have to shift down all of our aliens. So it's iterating through our aliens array, and for each of these aliens, it is shifting them down. So this is going to, you know, the amount of work that this for loop has to do is based on how many aliens we have in our aliens array. Obviously, we need, you know, if things shift down, we have to shift down every alien. But for detection, like hit detection, we could optimize this better since we are actually checking every single alien, which is a little bit expensive. But for now, it works. So we're just going to roll with it for now. It doesn't matter. This code base is not 100% optimized yet. That's totally fine. It works. And as long as we don't have like a million different things on the screen, it's not going to be slowing us down too much. Okay, this section here is what goes through and deletes bullets. We're deleting bullets with splice. You can see that we are iterating backwards from the end to the beginning of the bullets array. This allows us to delete bullets without messing up our iteration, because as we delete bullets, the length of the array is going to change, but then it's not going to matter since the next step is going to be one less from where we are. If you don't understand what I mean by this, that's fine. Just go check out backwards iteration and understand like how that's working, and just think about it for a bit. For this, it is going through and deleting any aliens marked to be deleted. And then that's it. So that is the end of the draw function. So a lot of different sections in here. Definitely comment these sections so that you understand like all the different sections and you can keep track of them. Um, yeah, I don't necessarily want to add too many comments to all this stuff because some of the logic in here should be very straightforward, should not be very complex to understand, and you should be able to read it and understand what it's doing. But if you want, you can always add comments. So you'd be like, okay, so I've added comments to these sections. Hopefully, that makes it clearer. I'm just trying to make this as clear as possible. In general, if your code is well structured and the sections of your code are clear and the code itself is straightforward, it's generally considered not best practice. It's generally considered overkill to add like comments to everything, explaining every single thing. But since this is a beginner project and we are trying to make sure we understand everything and that it's easy for us to zoom around in the different parts of this code base and get oriented and not lose track of where we are. Um, I'm adding a lot of extra comments just so that everything's very clear, even if the comment ends up being unnecessary because the code is straightforward, right? As you read through all of this code multiple times, you are going to remember the different sections of this code. It's just like reading a book, right? Like the more times you read a book, the more familiar you are with that story. And so you will remember like things in the story. So, same thing with code bases, right? Code bases, it's kind of like memorizing a book. Um, we have all the different sections of the book, all the different chapters of the book, right? And if our game actually gets too big, we might want to split our one file into multiple files if that helps us to kind of segment the code and be able to organize it better. In this case, this project is not going to be very large. So we should be able to just keep all the code in one file, and it should, using comments and function names, we should be able to easily segment our code into pieces so that we can skim through our code and find the sections that we need. Now keep in mind when we are working on our code base, we can use the find functionality, right? So if we need to find anything, we can, search for it in the search, right? So like move, like if we want to look up all the places where we moved stuff, right? Okay. So from here, you might ask, okay, and oh yeah, this is the basic player controls. I kind of briefly went over this. You can read through this and understand it yourself. Um, you might need to look up some documentation, right, on P5.js. So the next steps here are, okay, well, we have this basic project. We have this basic game, and we're trying to make Space Invaders. So, what are some things you want to ask yourself? What are some things that are missing from our current project template that we want to add for this project, for this game? Okay? So, think about what we're missing and what we might want to add and you can go spend some time outlining like core functionality of the game and various things that we're probably going to need to add. You can pause the video. I'm going to actually walk through it myself and just do my own notes for functionality in case you forget something. And then if I'll have a section of this video where you can skip ahead to it if you just want to see the end result. So I'm going to walk you through my brainstorming process, and then if you don't want to waste your time, then you can just skip to the end when I'm done. Okay. So go if you're going and doing this yourself, go open up a document or piece of paper or whatever you want to do, and write out the outlining of all the different functionalities and features that you feel like we need to add to this game to start with for core functionality to get it to be fully a Space Invaders game. And then when you're done, unpause the video. All right, so I'm just gonna do this in some kind of document. So I'm just gonna open up a Google document. And I'm just gonna write notes on this. Nothing really that complicated, right? So we're gonna say game functionality. So we want to track player score. We want to track player lives. We want to track the level. So for the aliens, we want to give them the ability let's just do this simple. Alien attacks. What specifically that means, we will outline more when we work on it. So we want to have alien attacks, right? The abilities for the aliens to shoot back. That means we need alien bullets, alien attack frequency. So levels, we want to track the current level, progress to the next level once we shoot all the aliens. We want to do game over checking. What are some other things we might want? Let's see. Adding player lives when we clear a level. Our current player movement functionality is a little bit buggy if you're pressing multiple keys. So there's some issues with the logic that we can fix. That's a whole thing. That might be like a whole video, like player movement functionality, right? Alien attacks. Oh, maybe we want to have like different types of aliens. Let's see, maybe different types of attacks. So like different types of bullets. So obviously, with different types of alien attacks, you can have different behavior of those attacks, right? You could just have it dropping down a straight line. You could have it moving in a diagonal pattern, an erratic randomized pattern. You could have like a guided missile. These are all things you could potentially add in. You could have different types and sizes of aliens. And yeah, so like I think for the most part, oh, I guess they have like the UFO alien, like a random UFO moving across the top. So I think for the most part, unless I'm just blanking out and missing something. So yeah, so as soon as we create alien bullets, we need to create player hit detection so that we're testing to see if we've been hit by alien bullets or not. I believe this is most of it. I mean, at least the major points. So when we go in and start working on these different features, we're probably going to expand on these notes, right? So for those of you who are joining us, so I'm going to mark this as a new chapter, right? The end of creating these notes for functionality. You might have something similar. You might have some additional different things. I've tried to segment all these different functionalities into their relevant sections. Obviously, you know, this is just your working notes. It doesn't need to be perfect or anything. This is just for you to keep track of what you're doing. So as you decide to work on different parts of this game, you can go in and like expand the notes with more details as needed. And then when it's done, you can label it as done. And this helps you have a sense of progression. Also helps you keep track of um, all the things and details you need to do so that it's not just all in your head. You should not be just winging it all the time. This is creating too much work for your brain. You need to have a clear mind to be able to think about what to do next on each of these steps. So, in order to have a good and happy and easy workflow, you need to write things down. You need to have notes for all these details, things that you need to do. You need to have like lists of things that you need to do, and you need to keep track of what you've done, and so that you don't get lost, right? Obviously, when we finish adding a feature, we want to mark it in our notes as done. If new things come up, like, you know, maybe we'll have bugs, or maybe we'll have um, refactors. So that could be for optimizing performance. It could be for making our code base more organized and easier to read, right? If we're writing a lot of bad code, sometimes we write bad code because in the moment we're rushing through it and we have some ideas and we don't want to lose our train of thought. We can always go back and reread our code and decide, oh, do we want to structure this differently, right? All right, well, you may have something that looks exactly like my notes. You might have something that's slightly different. Uh, whatever you have is fine. You decide what the core functionality of this game is going to be, right? Um, this is just part one, right? This is for core game functionality. Later on, if you decide that you want to add more functionality, right, you can always say like, expand it, or like refactoring, major refactors for increasing functionality of game modules, right? So that's stuff in the future to think about. But for now, we're just going to start simple. Maybe you think Space Invaders is boring and easy. I want to make a more challenging game. I want to make a more crazy shooter game. Sometimes we call it like a bullet hell game, where you have lots of different enemies. They're all shooting at you. You have to dodge them, and then you're shooting back. And maybe you are moving your spaceship around across the screen, and you have a lot of different types of power-ups and bullets. So if you want to make that type of a game, by all means, go for it. But if you want to build this Space Invaders game first, because it's more straightforward, start with this, and then after that, you can go and make a new project and think about how you want to structure your new project for a more complex game, right?